This is another video from Pathfinder. It is from the chapter EMI and AC. Build up your understanding, question 44. So this question is that there is a rubber coated wire. It is bent in the form of rigid. So this is the rubber coated wire, sinusoidal, and then its end P and Q. So this one end P, this is another end Q, are electrically connected with the help of a straight conducting wire. So this is a straight conducting wire, and thus you are making a closed loop of total resistance R and length L, right? So this is a total resistance. These are two ends, and these two ends you have joined by a wire of resistance, total resistance R and inductance L. Amplitude of the sine wave is A naught. This is line AA. Right of this you have magnetic field. So that is what is written here, pointing perpendicular to the plane. Now it is made to move with constant velocity. So it is moving like this with constant velocity V, and it is entering the magnetic field. And now it says that if one cycle of sinusoidal enters the region of magnetic field in time capital T, then we have to find average thermal power generated in the loop while it is entering the region of magnetic field, right? So it's a very good question, and it is very highly probable this can come in this year JEE advanced. So let us see how do we approach this. So here, right now, this is like a sine wave, and this is actually a sine wave, right? And it is moving like this. So it's like, if I want to write the equation of this, you can write this, right? So it is like similar to the wave equation. And at t equal to 0, this end is here. So if you complete this, this is actually the equation of what? This is actually the equation of y equal to a sine kx. So since it is moving with the velocity v towards right, so x will be replaced by x minus vt. Correct? So that is what I have done. That will give us the equation of this wave, which is moving towards right. Fine. So this is the equation. V is velocity, k is 2 pi by lambda. So k is 2 pi by lambda, and t here is, see, t was given, right? T is here is lambda by p. Now what is lambda? So lambda I am taking as this. So that is what is given. Here, this is capital T, and it is for one cycle. So one cycle, wavelength is lambda. Fine. Now, what will happen when it enters? Then EMF will be induced in this. Because of the induction of EMF, since it is a closed loop, there will be a current, right? Now let us see how much EMF will be generated. So suppose, now see this diagram here. Suppose this part has entered. So if this part has entered, then EMF induced is what? Motional EMF induced will be BVL, right? So here V is magnetic field, V is the velocity, and L will be this length. Correct? This concept, you know. So if wire is bent like this, and it is moving with V, and magnetic field is B, then this length, right? So we take this length for induced EMF. So here also from the same logic, this length will be taken, right? So this is nothing but the y coordinate, and y coordinate we have already found. Correct? So now you're getting the idea. This becomes a question of actually AC circuit. So this is the equivalent circuit equivalent because it has inductance also, resistance also, and induced EMF is generated. So equation will be IR plus LDI by dt is equal to induced EMF, right? This is basically a LR circuit with AC EMF. Here now IR LDI by dt, and then V remains V only, V is V, and L. What is L? L is this Y coordinate. Y coordinate we have already found. So this becomes A naught sine 2 pi by lambda. K I have written as 2 pi by lambda, and K into V is omega, so 2 pi by T. Right? Now you know how to solve this. Li V naught sine omega t. Current is what? V naught root over R square plus omega L whole square sine omega t minus 5. You can use complex number for this or phasor method. Anything is fine. So here now, since we have to find out the average power generated, we only need RMS value. So from this, we will extract the RMS value and use the formula IRMS square into R. So I naught will be what? From this V naught is this, VB A naught, right? Divided by R square as it is, omega. What is omega? 2 pi by T, right? So 4 pi square by T square L square. This is I naught. RMS will be I naught by root 2. So IRMS is equal to I naught by root 2. And average power generated is IRMS square into R. So this is square, this by root 2. So that is how this half will come. I naught square into R, right? So this T square I have taken here, that is how this T square comes. Fine, so that's it. That's the solution. It's a very, very good question and very highly probable for JEE Advanced 2022. Thank you very much. If you have liked this video, then please hit a like button and please subscribe and then share this video with your friends also. Thank you very much.